After a planet forms, many things can happen to its surface. And so here we're going to look at some of the things that affect the surface of a planet, and then also look at the things that affect the age of the surface of a planet. One thing that affects the surfaces of all the planets and the moons are impacts. Impacts can be from pieces of asteroids or comets, or entire asteroids or comets. And when an impact occurs, you get the formation of craters. Our moon is an excellent object to look at for craters. Every one of these little round features that you see, plus these bigger features, are all the result of impacts. And although you won't see as many craters on some objects as others, everything has been hit. Another factor that affects the surface of a planet is geologic activity. Volcanoes are certainly the most dramatic version of that, but also plate tectonics and other tectonic forces can affect the surface. And in all these cases, what happens is that features that were on the surface are going to get erased or altered as a result of these events. And if you have plate tectonics or volcanoes, you are going to have the release of new material. In the case of a volcano, you've got lava coming out, and that new material is going to cover up the old material. So you have brand new stuff on the surface that wasn't there before. If a planet has an atmosphere, or if it has water, then you are going to get the effects of weathering and erosion. And these have the end result of erasing features through the erosion process. Whether it's wind erosion on Venus, Earth, or Mars, or water erosion on Earth or Mars, you will get features that develop that definitely have altered what was once there. And so these erosional features will change what the surface looks like. And whenever you have people, you are going to have something happen to change the surface. We are very good at modifying surfaces. We like flat surfaces, so like in this picture, if we've got a bulldozer, odds are we're going to smooth it out and make it nice and flat. So any feature that was here on this stretch of land at one time in the past isn't there now. And even places that we have visited elsewhere in the solar system, the people who walked on the moon left footprints, and then the later Apollo missions, they actually had a little rover, so there are tire tracks. We picked up rocks and moved them around, took some rocks home with us, and even remotely, where we have landed on Mars, we have left tire tracks there with our rovers. So people, wherever we go, we are going to end up modifying the surface. The age of the surface of a planet then is based upon how old are the rocks on the surface. Not how old is the entire planet, but just the stuff on the surface. And in order for the surface to be a different age than the planet as a whole, you need to have geologic activity. Because anytime you have things like volcanoes, you're going to have new rock forming on top of older rock. And so each time a volcano erupts, it's creating young rocks on top of older rocks. And so the surface around a volcano, an active volcano, is going to be some of the youngest material you will find on a planet. One way to get at least a rough estimate of how old a surface is by counting craters. So here we've got Mercury. Mercury is teeming with craters. So there are craters everywhere on the surface of Mercury. And this picture isn't very good, but there are lots and lots and lots of craters. The more craters you've got means that every impact that has ever occurred is still preserved. Nothing has happened to erase those craters. So if there's lots of craters, then that surface is telling you, I've been around a very long time and I am old. So we know the surface of Mercury is very old. There is no active geology on Mercury to create a younger surface, to erase the older craters. Same thing is true for our moon. So if you can see craters, then crater counting is at least a rough way of estimating how old a surface is. If you are fortunate enough to have access to actual rocks from a surface, then you can get a precise age through a process called radioactive dating. And the idea behind radioactive dating is the fact that some elements, the nucleus of that element, is unstable. And for whatever reason, that unstable element is called the parent. And when it decays, there are different ways of decaying, but what this picture illustrates is the nucleus spits out something. In this case, the nucleus is spitting out 2 protons and 2 neutrons. And so what you're left with is a brand new element. It's got a different number of protons and neutrons in the nucleus, so it is a different element. And what it turns into is something that is stable. And again, the terminology is it's called a daughter. We know how fast different elements decay. So by looking to see how many daughters are there in a sample versus how many parents there are in a sample is a way of determining the age of that material. And there is another more detailed tutorial specifically about radioactive dating that I recommend you watch to get a fuller picture of this process. But whether it's counting craters or analyzing daughter and parent ratios, we can get a general idea of how old a surface is and how old a material is.